Hello students, and welcome to the CompTIA Cloud+004 Exam Course brought to you by Third Level Technology. I am your instructor, Jim Herby. In this episode, we're going to continue in Module 1 in the exam objectives by discussing Section 1.3. Our topic is Cloud Networking. Let's begin. We're going to begin our discussion of cloud networking with VPN, Virtual Private Network. VPN is a common technology that we use that allows remote users to have secure encrypted connections to private internal data in a cloud environment. We use VPN to allow our users to have access to our secure data in our hybrid cloud environments. This is where we will have a private cloud where we store all of our critical data and applications. And then we will have a public cloud that will be accessible to our standard users for their normal work operations. VPNs can come in both site-to-site as well as client-to-site connectivity. Site-to-site would be building-to-building. Client-to-site is individual remote user with access to your site's servers. Another cloud networking configuration is a dedicated cloud connection. A dedicated cloud connection is one where you have a direct connection between the customer's premises and the cloud environment. This is where you can have high bandwidth connections between your on-premises infrastructure and the cloud environment. A dedicated connection will have very low latency. You have very high reliability and availability because you have that direct connection that is not going to be susceptible to the disruptions you have on your public internet connections. We use dedicated cloud connections with our fiber optic connections, and they are a key part if we have compliance requirements for high-speed data transfers. Next, we're going to discuss application and network load balancing. Load balancing is when we have a certain type of network traffic and we want to distribute it amongst multiple servers. One way we can practice load balancing is with applications. An application load balancer will be a device or a software interface where we can manage and configure all of the application traffic that's coming across our network. Each user that is interacting with an application is called an instance. And what we can do is we can configure different types of rules for what types of application traffic can go to specific users. All of these configurations are OSI layer 7. This is application layer routing. With application load balancing, we can improve our redundancy by having multiple servers that can handle our application traffic, as well as fault tolerance by creating rules that will reroute traffic when we have a user that has an unhealthy instance of an application. A second way that we can use load balancing is with a network. A network load balancer is when we can distribute our network traffic at OSI layer 4. These will be rules and policies that will be created based on IP protocol data. This is where we can create rules about how we can distribute traffic based on TCP and UDP protocol types, port numbers, as well as whether data is encrypted with TLS or unencrypted. Many times we use our network load balancer when we have high volumes of traffic. This could be our web traffic, email, and others, where we need to have low latency and high throughput. Next, we're going to discuss application gateways. Application gateways are a utility we have where we can manage our web traffic related to our applications. And we can perform advanced filtering using a web application firewall. You might see this abbreviated as WAF. A web application firewall is where we can create our own filtering rules for our application traffic. We can create rules based on whether an application traffic is encrypted or unencrypted. We can create rules based on URLs, as well as creating advanced routing rules based on where we want certain types of application traffic to go on our network. Another thing we can use with our application gateway is SSL termination. SSL is Secure Sockets Layer. We can use our application gateway to drop SSL traffic off the network if certain types of traffic is coming from outdated websites or revoked or expired digital certificates. Next, we have CDN, Content Delivery Network. Content Delivery Network is where we can distribute our cloud resources to our edge locations worldwide. Think of this as a way to update our cloud environments. In your CDNs, you will have edge locations. These will be centralized areas that are distributed globally and internationally that provide certain types of storage and other computing resources to businesses and customers within that geographic area. And with CDNs, we can ensure that all of the cloud resources are going to be consistent at all of these different edge locations. We also can provide caching. Caching is where our end users can store locally dynamic and static content for faster delivery and lower latency. CDNs also help to reduce our server load. Because we can distribute our content across the entire network, it allows our user experience to be very quick for website performance, accessing applications, and others. Next, we want to discuss cloud networking firewalls. A firewall is a way that we can configure filtering rules for traffic and access to our cloud environments. It's a way that we can control our inbound and outbound traffic based on the predefined rules that we create. We can use our firewalls to protect our cloud access from unauthorized users and cyber attacks. Our firewalls can use very advanced features such as packet filtering, application layer filtering, as well as stateful inspection of our data packets. Firewalls also can be segmented. We can create different firewall rules for different network segments and subnets that can enforce different policies and compliance requirements for different users and departments. Next, we have virtual private clouds, VPCs. A VPC, a virtual private cloud, is where we can create an isolated, customizable virtual network within a cloud provider's infrastructure. It allows us to control our network's IP address range, subnets, and routing configurations. With our VPCs, we also can enable and ensure that we have secure encrypted communications between all of our cloud resources and our on-premises networks. Next, we're going to discuss peering. Peering is a technique where we create a direct network connection between two virtual private clouds. This allows our VPCs to exchange data without having to use the public internet. With peering, we can reduce our data latency because we have that direct connection. Peering is also a technique that allows us to enhance our security because we are keeping all of our network traffic within the cloud provider's network. Many times we use peering for multi-tier applications and data replication across different regions. Next, we have a transit gateway. Your transit gateway is going to be a central hub that will connect multiple virtual private clouds and on-premises networks. You can have one single gateway where you can manage all of the network configurations related to your routing and your connectivity. Transit gateways are very important if you have high throughput and scalable network architectures. If you're using fiber optics across different sites, that's going to be very high speed data traffic, and you want to make sure that your cloud providers have the appropriate resources to handle the amount of throughput that your network is pulling out. Transit gateways also allow us to do large-scale cloud deployments when we want to implement some type of new resource to users across a large, dispersed geographic area. Next, we're going to discuss subnets. Subnets is a networking technique that allows us to divide our virtual private clouds into smaller segments. This allows us to organize and manage all of our secure data resources. Within our subnets, we can create different ones related to both public and private resources, and we can designate subnets for different types of data. Subnets are very important because it allows us to manage and allocate all of our IP addresses and configurations across the network. Next, we have VLANs. A VLAN is a virtual local area network. A VLAN is a cloud networking tool that allows us to logically segment a physical network. This is where we can take physical hardware devices, such as routers, switches, servers, and others, and we can take these different types of devices that may be in different physical locations, and we can segment them into their own VLAN and manage the traffic and security for the devices that we place in each of these VLAN networks. This allows us to isolate different types of traffic, and we can also allow multiple VLANs to support a single physical network. So we can take one network and divide it into multiple VLANs and still have it within the same silo of infrastructure. VLANs are very important to allow us to enhance our network performance and reduce the need for broadcasting our domain security. We also have SDNs. An SDN is a software-defined network. An SDN is where we will centralize all of our network management through a software-based controller. It allows us to dynamically program all of our network configurations. With SDNs, we are doing a process called decoupling. Decoupling is when we remove the configuration of our hardware devices from a manual to a software or automatic. With manual configuration, your IT staff will have to go to the device's settings itself and change configurations as needed. With SDNs, we can do it from an interface, and those can then be applied to the device through the connection. With SDNs, we can do automated provisioning of applications, as well as scaling up or down depending on our user's needs. Next, we're going to discuss the Border Gateway Protocol. You might see this abbreviated as BGP. The Border Gateway Protocol is a very important cloud networking protocol that we use to exchange routing information between autonomous systems on the internet. It allows routers between different businesses and organizations to update their dynamic routing tables. This allows us to achieve efficient routing paths of our data, as well as to have load balancing, because we can reroute network traffic to different paths if we experience congestion or interference of any kind. BGP is a standard protocol if you work in your large-scale enterprise networks. Next, we're going to discuss static routes. A static route is when we will define a fixed path in our cloud environment for traffic to a specific destination. It gives us a straightforward routing path without having to configure using complex routing protocols. We should use static routes when we want to have a simple configuration to a specific device. It also will require us, though, to have manual updates. So if we need to change the configurations, just be aware that that's something that if you want to maintain the static nature of the route, you will have to do it directly on the device. Related is routing tables. A routing table is when we can change dynamically how a data packet is going to go from source to destination across the network. We can store the information about all of the different network paths and how data packets were forwarded from router to router. It will include data about the destination IP address, all of the hops, the different routers that the data packet went, and then updating these in a table that can be shared with other networks or internal routing devices. That will conclude our discussion of Section 1.3, Cloud Networking. In our next episode, we will move on to Section 1.4 in the objectives, and our topic will be cloud storage. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.